This is activity 3. What's the equation for lesson 7? All, some, or no solutions. And in this activity, you're given 3 equations, and you're asked to complete the right side of the equation, the expression on the right side, so that it either equals the expression on the left side, so that all values of x are true for the equation, make the equation true, or complete the right side, the expression on the right side, so that it's not equal to the left side. And in that case, there are no values of x that will make this equation or these equations true. So let's see what that means, actually. So the first problem, you have 3x plus 6 equals 3 times x plus some unknown in the square. So what are you going to put in the square that makes the right side equal to the left side? Well, you work through this, use the distributive property, and so now you have 3 times some value has to equal 6 over here. So 3 times this value, whatever it is, has to equal 6. Well, 3 times what number equals 6? That's 2. So if I replace the square with 2, then I'm going to get the same expression on the right side as I have on the left side. So if I graph those, so now I have 3x plus 6 equals 3x plus 6. So whatever value I use for x, that's going to get multiplied by 3, and 6 is going to get added to it, and the same thing is going to happen on the right side. So if I take this expression on the left side here, and I write a linear equation with that expression, I'm going to get this line that has a slope of 3. So that what that means is that whatever the length is along the x-axis, the y-axis is 3 times, the length along the y-axis is 3 times as long. So if it's 1 unit, this length is 3 units. If it's 2 units, 3 times 2 is 6. This length is 6 units. And it's going to, this line is going to intercept the y-axis at positive 6, because this is the y-intercept form of the equation, or the slope-intercept form of the equation, where the coefficient of the variable is the slope, and this is the y-intercept out here. So y equals mx plus b, b is the y-intercept, m is the slope of the equation. So now I have an equation on the left side equal to an equation on the right side, and they graph, or the line that's the graph of each equation ends up as a line that's the same line. Has a slope of 3 and a y-intercept of 6. So let's see what happens in the next one. So in this case, you have x, and you're going to subtract 2 from it. And on the right side, you have some unknown value. You're going to subtract x from it, and you're going to take the opposite of that. That's what this negative sign out here means. So to simplify that, remember that this is negative 1. So now I'm going to distribute that negative 1 to the unknown in the square. And also I'm going to change this to adding a negative x, so adding the additive inverse. So now if I distribute that negative 1, this is the opposite of whatever goes inside this square as the unknown, plus x. The opposite of a negative x is x, positive x. So now I can use the commutative property and rewrite this so it looks very much like what's on the left. So I just move this x over here, move this negative 1 times this unknown over here. So that shows me that this is negative 1 times 2, and over here this has to be negative 1 times, to make them equal, this has to be a 2. So negative 1 times 2, so I subtracted the x from each side, or added a negative x, same thing, to each side to get rid of it, and I'm left with negative 2 equals negative 1 times this unknown. So what the unknown has to be to make both sides of this equation equal, this has to be a 2. So if you replace it with the 2, you get this equation up here, and this equation will be true for whatever value you choose for x. This equation also shows you that subtraction is not commutative. I will not get the same answer if I take x minus 2 and just switch what I'm subtracting to 2 minus x. I'll get the opposite of that. So we'll look at that more later. So subtraction is not commutative, so you can't just move them around. And a graph of them, so the same idea. So on the left side is an expression that's equal to the expression on the right, on the right side. And if I graph each side, so x plus -2, if I write that as a linear equation, and a graph of this equation is a line that has a slope of 1. So this is for every unit of x, y increases 1 unit. So 1 unit, 1 unit, 1 unit over, 1 unit up. 1 unit over, 1 unit up, and it crosses the y-axis at -2. Remember, this is the slope-intercept form of the equation. Y equals mx plus b. B is where it crosses the y-axis at -2, and m is the slope. And in this case, you have to remember that there's a 1 here. So m has a slope. So this equation has a slope of 1. So it's the same line on each side. So you just write x and you subtract 2 from it, you get the same line, no matter what values you choose for x. Okay, the last one. It's a little bit harder because you have to simplify this left side first to really see what's going on. So simplify that to 3x minus 2, or 3x plus a -2, same thing. And that shows you on this side, if I add 2, or if I change this to adding -2 and then add a +2 to get rid of it, so use the additive inverse. Whatever I do to get rid of this 2, I do the same thing on this side to get rid of this 2, and I end up with 3x equals this unknown. Well, 3x has to equal 3x. So this has to equal 3x, and so now both sides of this equation are equal to each other. So whatever value I choose for x is going to get multiplied by 3, and 2 is going to be taken away or subtracted from that. And that's what this line shows you right here, this pink line. So again, over here is both sides of the equation are equal to each other. One expression on the left is equal to the same expression on the right. So if you take one of those expressions and write it as a linear equation, a graph of that equation ends up being this line. And so whatever value you choose for x, you multiply that by 3 and add a -2 to that. And so you get the same line using each side of this equation to write this linear equation over here. The point is you get the same line. And so all values that you choose of x, the same thing's going to happen on each side. So you end up graphing the same line. Now, what if you put a value in here for the unknown that makes these two sides unequal or not equal to each other? So then there would be no values of x that will make this equation true. So let's go through and look at this again. To make it true, we put a 2 here. So this is 2 times 3 is 6, and this is 6 over here. So anything I choose to put in this square other than 2 will make adding it to 3x something other than this 6. So to make it true, it was 3x plus 6 and 3x plus 6. So you want to change it so you come up with something other than 6 here. So you want to multiply this 3 by some factor other than 2. So I'm talking about two things here. One is something other than 6, and you get something other than 6 by multiplying 3 by some factor other than 2. Well, let's choose something that's pretty easy. Let's choose 0 here. Let's make this 0. So 3 times 0 is 0. And so now it's 3x plus 0. And that equals 3x. So now on this side we have 3x plus 6. And on this side we have 3x. So whatever we choose for x is going to get multiplied by 3. Same thing on this side. But on the left side, 6 is going to get added to it. So on the graphs, so if I take this side and make a graph of it. So I'm going to write this as a linear equation. A graph of that equation is this line that crosses through the y-axis at +6. This is the y-intercept, has a slope of 3. So whatever I choose for x gets multiplied by 3, and 6 gets added to that. So if I choose, well, let's just say it that way. But on the right side, whatever I choose for x, it just gets multiplied by 3, and nothing gets added to it. So this goes through the origin, 0, 0. This is a proportional relationship, but whatever point I choose on this line, the proportional relationship, let's go down here, 6 gets added to it. So there's a parallel line that's 6 units greater in the y direction for every single unit on this line. So these two lines will never intersect. There will never be a common value of x that will make these expressions equal to each other at the same time. So you end up with 3x plus 6 is not equal to 3x. And again, starting out with the same thing, but on the left side you're adding 6 to it. So it cannot be equal. You can't find a value of x that will make the right side equal to it, because you're always going to add 6 to it. Okay, the next problem. This problem, when we worked it out, we figured out that you had to put 2 in here to make both sides of this equation equal to each other. So any value, you want to choose any value other than 2 will not be equal. So if I choose something that's not 2, then the left side will not be equal to the right side. So again, let's choose the simplest thing, which is choose 0. Something that's not 2, well, 0 is not 2, so choose 0. So you get down to here, you have the expression on the left side, the expression on the right side. So I'm going to choose 0 here. So -1 times 0 is 0. 0 plus x is x. So now we have the same thing that we had just a moment ago. We have x, but now we're adding -2 to it on the left side. We have x. We're not doing anything to that value on the right side. So these two expressions are not equal to each other. So a graph of them, if I graph the left side, y equals x plus -2, and I draw the graph of that, I get a line that has a slope of 1, and it crosses through the y-axis at -2. But if I graph the right side, that's just y equals x. So it has a slope of 1, and it goes through the origin right here. So this just has a line that's y. Whatever I choose for x, y is the same thing. So if I go out here 1 unit for x, and I go up 1 unit for y, 1 unit for x, 1 unit for y, 1 unit for x, 1 unit for y. But nothing is getting added to that. Down here, same slope, 1 unit for x, 1 unit for y. But then a -2 gets added to that. So let's go here. 1 unit for x, 1 unit for y, but then -2 gets added to that. So it drops down to here. It's a parallel line that's always 2 units less than its corresponding point on this line. So these two lines never intersect. So there's no value of x that will make these two expressions equal to each other at the same time. So these two expressions are not equal to each other, and they will never, there's no value of x that will ever make them true. So it's true for no values of x. And the last one, remember we had to simplify this a little bit to 3x minus 2, or you can rewrite that as 3x plus a -2, 3x plus a -2 on this side. So now you have to think about this. You have to add 3x because it has to have the same slope. So you have to get the same slope on each side, which is 3 as a coefficient of x. But then you have to add some value to that 3x other than 0, because you have to change what gets added to 3x to something other than -2. A little bit hard to think about. I'll show you in a minute what I'm talking about. It's a little bit easier to see than to think about it in your head. But any value other than 0, add an amount other than -2 to 3x, then they cannot be equal. So let's see how that plays out. So let's say I take 3x and I'm going to add a +2 to that 3x. So that's what's going to go into the square here. So 3x plus +2, and right here 3x plus +2, and then what happens is -2 gets added to that. Well, what's a +2 plus a -2? That's 0. So on the right side, you're going to get 3x. So you're going to have 3x plus a -2 is not equal to 3x. Because again, whatever value you choose for x, you multiply that value by 3. But on the left side, you're going to add -2. On the right side, you're not going to add anything. It's going to be 0. So the equation, so if I add 3x plus +2, and if I replace the unknown square here with 3x plus +2, and that +2 plus -2 equals 0. So you end up with 3x on the right side and 3x plus negative 2 on the left side. So a graph of this left side, rewrite this as a linear equation. A graph of that equation is a line that crosses the y-axis at negative 2. Remember, this is the y-intercept right here, negative 2, and it has a slope of 3. So for 1 unit in the x direction, the length along the y-axis is 3 times that. 1 unit 3 times, 1 unit 3 times. So that's always going to be 2 units less than whatever I find as the corresponding point on this line. So if I take the right side and write an equation for the right side, that's y equals 3x. So I go over 1 unit up 3. But the pink line, the expression on the left says, okay, now subtract 2 from that. So that's going to go down 2 units. And so this is go over 1 up 3 and then down 2 units to land on this line here. So again, they are parallel lines. They have the same slope. They just cross the y-axis at different points. And so there is no value of x that will make these two expressions equal to each other at the same time. Another way of saying that is to make these two equations equal to each other at the same time. They don't share a common point, and that's something that we're going to get to in a little while. So they don't intersect, they don't share a common point. There's no value of x that will make this equation equal to this equation. And a visual, I like the visual of the parallel lines because it shows you exactly what's going on. So they are not equal to each other. 3x plus negative 2 is not equal to 3x. Starting out with some value, same value, but on the left side you're adding negative 2 to it. So it's always going to be different. It's never going to be equal. So if you look at them all, 3 of them at the same time, so this is the first equation, the second one, the third one. So make both sides equal to each other. Then if you write an equation, a linear equation for each side, you get the same linear equation, you get the same line. So for whatever value you choose for x, it will always be true. You'll always get the other line because it's the same line. But on the other hand, if you look at each one of these separately, this equation, this expression ended up being 3x plus 6 is not equal to 3x. So if you draw the graph of the linear equation for each side, you get parallel lines. Same thing with the next one. 3x plus negative 2 is not equal to 3x. So if you draw a graph, make each side a linear equation and draw a graph for that equation, you get parallel lines. They never intersect. They never have a common point. There's never a value of x that will make each of these expressions equal to each other. Last one, the same thing. Make each side a linear equation. Y equals x plus negative 2, or y equals x. Draw the graph of that equation, which is a line. You get parallel lines. Same slope. They just cross the y-axis at different points.